All right, so today we are going to be talking about chemical reactions. And first we have to have a definition. So this is a change by which one or more reactants change into one or more products. So typically in the reactants, we're going to break the bonds down, rearrange the bonds, and then form them back in the products. Chemical reactions are represented by equations, and they have to be balanced. These chemical equations must be balanced because of the law of conservation of matter, which states that matter cannot be created or destroyed. It can only change form. So because of that, it has to be balanced on each side. Therefore, the amount of the reactants must equal the amount of the products. As we go through the reactions, we'll be balancing different equations. So some tips: start by writing the unbalanced formula. Oftentimes I will go ahead and give you the unbalanced formula. Balance your metals first, the ones underneath the staircase. Balance the non-metals next, the ones above the staircase. Balance hydrogen and oxygen last, because typically there's a bunch of them. You cannot change the formula of a compound to balance an equation. You can only change the coefficients. All right, so as we look at this, and first thing I want to show you is that I know that 1 times 1 does not equal 2. I know that 1 times 1 equals 1. All right, so let's look here. Let's count. We have 1 carbon here, and we have 1 carbon here. So we have 1 carbon in the reactant side and 1 carbon in the product side, which means that they are balanced. So good. Now we have 4 hydrogen on the reactant side. Okay, so we have 4 hydrogen on the reactant side. And if I go over here, my coefficient is 2. And 2 times 2, which there's 2 hydrogen molecules, and then we're multiplying that by 2, is 4. So am I balanced? I am, yes. Okay, now to oxygen. Here's our coefficient here. 2 times 2 is 4 here. Then we have a coefficient over here, and we have 2, but we just have 2 times the 1 oxygen. So we have 2 right there, but then look right here, we have 2 oxygen over here. So we actually have 2 times 2 over here as well. And then we have 4. So this is a balanced equation. All right, so this is your checkpoint. Pause, determine the reactants, determine the products, and then balance the equation. So I'm going to pause. You need to pause the video, and you need to do this on your own. All right, so the first thing is the reactants are here on this side of both of the formulas, and the products are on this side. So for the reactants and products, you just have to know this is the left side are the reactants and the right side is the products. All right, so we're balancing our metals first. Sn is a metal. We have 1 of those over here, 1 of those over there. Check, check, we're balanced. Now we get into oxygen and hydrogen. It doesn't really matter which one you do first. We look over here, we have 2 oxygen, but we only have 1 over here, which means we have to add a 2 right here in order to have 2 oxygen. So now we're balanced, 2 oxygen, 2 oxygen. Now we have 2 hydrogen over here, but because we had to add this 2, now we have 4 hydrogen. So we have to come over here and we have to add a 2. So now we have 4 hydrogen over here and 4 over here, and we're balanced. All right, next one, metals first, Ag, Ag2. We know we have to add a 2 right here at the very least. We may change that later, but we know we need at least 2 to have our Ags check out. Salt, we have 2 NAs over here, or I'm sorry, sodium, we have 2 NAs over here. So we know we have to put the Na, we have to put a 2 over here to balance them out. We may have to change that later. Now we come back, because I added this 2, I have 2 iodines on this side, 2 iodines on this side, so we're balanced there. I have 1 S on this side and 1 S on this side, so we're balanced there. All right, so just a little bit more information on the equations. On the left side of the equation contains the reactants, and on the right side contains the products. The coefficient is the large number in front of an element or a compound. this indicates the number of the reactant or the product. So if you look here, this coefficient right here, 2, it applies both to the hydrogen here and the oxygen here. This 2, this subscript 2, only applies to the hydrogen. So that's really important to keep in mind. All right, a plus is used to separate the reactants or products. An arrow is a yield, and if you have arrows that go in both directions, this represents a reaction that can go either way, that the products can become the reactants and the reactants can become the products. It's like reversible. S is solid state, L is liquid state, G is gaseous state, and AQ is aqueous or dissolved in water. Delta, this triangle is a delta, and delta indicates a change. I'm sorry about the background noise. Delta indicates a change, or they can say heat, which basically means that heat is added to make a reaction go forward. Now, PT denotes the presence of a catalyst. If you remember from biology, a catalyst is something that can speed up a reaction but is not used. Therefore, it is not required to be balanced. So our checkpoint here is basically you just need to tell me what these things mean, and you'll know what they mean by looking them up in your notes that we just took.